All right, so let's look at the second chart down here. I kind of moved our hydrogen bonding picture right here so that will help us explain these concepts. So the first demonstration we watched was this balloon and fire. So we tried to pop balloons using fire. You saw that a balloon in it that had nothing in it, just air, popped super fast when we lit it with fire. But a balloon that had some water at the bottom, when we lit it with fire, it popped slower. So we're talking about why did the balloon with water take longer to explode? So, if we think about this balloon over here, when we put the fire underneath it, it heats up that air, and this rubber, or whatever the balloon's made out of, it heats it up super fast and pops it right away, pretty much. It can get it really hot and popping very, very fast. When it has water in it, however, this water, the flame's going to come, and it's going to have to heat up this water here in order to pop the balloon. So when it comes, it's going to take some of that energy that would be popping the balloon, and it's going to have to start heating up this water. And so let's look at our hydrogen bonding and think why it might be hard for us to heat up water. And so you'll notice that water has these hydrogen bonds that are kind of strong. And so we're going to have to try to break up these hydrogen bonds in order for us to heat up the water. And so this heat's coming up and trying to break up these bonds. And so some of the energy is used to break those hydrogen bonds rather than popping the balloon. So something on here, why it would take longer, you can talk about the hydrogen bonds and how the energy is going to the water. Not the balloon. All right, hopefully that made enough sense for you guys. If not, email me with questions. So let's look at this next example. This next example is talking about heating up food. It says, "Dear microwave, please tell me why my plate is so hot and my food is so cold." And so when we heat up our food in the microwave, sometimes we get a plate, it's super hot when you touch it, but the food in the middle is still cold. So our important thing to remember here is that food is sometimes made up of water. So it's made up of water, not all, not 100% water, but food has more water in it than a plate has water in it. And so we can kind of use the same ideas that we're thinking about here with this balloon and the fire. When the microwave is trying to heat up our food and our plate, it has a plate here, it has the food on top. When the microwave is trying to heat it up, this plate is going to get hot fast. And this food is going to get hot slower. And why it gets hot slower is because of the hydrogen bonds in there. It takes longer, it takes more energy, and it takes longer to break those hydrogen bonds and to heat up the food. So, that is why your plate, way easier to heat it up. Because of the hydrogen bonding in the water and the food, takes it longer to heat up, and so it will be cold while your plate is still hot. So this next example, I used to live in California. I lived kind of close to the star. I lived about here in California, the picture cut off, but about here, a little bit left of that star, is where West Valley is. So you'll notice that where I lived and where West Valley are almost in a straight line from each other. However, living here, I never ever saw snow. Our summers were usually around 90 degrees, 80 degrees, stuff like that. But here in West Valley, our summers get super hot. We see snow. It's really cold in the winter, stuff like that. And so we need to talk about why that is. Why, even though they're almost the same, the same location on our map, that one, California, has way nicer weather than West Valley does. In my opinion, it has way nicer weather. So, why it's not as extreme. Now, you'll notice that California is right here by the ocean. This is the ocean over here if you're not really sure about American geography. That's the ocean. And so, California is by this huge body of water. And so, again, this water, we have the sun, and the sun, it takes longer to heat up and longer to cool down because of the hydrogen bonding that's happening in the water. So this has longer cool and heat up in water because H bonding. And because of that, the land that's right next to the water, right here, like this is California, this land also takes longer to heat up and cool down because it's close to this water right here. And so because it's close to the water right there, and that water is taking a long time to heat up and cool down, it helps keep California at a really moderate temperature versus Utah that's not really by any big bodies of water. And it's all due back to, again, this hydrogen bonding up at the top. And so our main takeaway with this is that hydrogen bonding makes it so that water takes a long time to heat up. Sorry. Alright, so something like this. This also sometimes is referred to as specific heat, just if you're looking for scientific terms. So it has a high specific heat. Water does. Alright, hopefully this video is helpful. We'll move on to our last one, and then you're all done. So move on to the next one if you need some help on it.